Hello everyone. In the previous lecture, I showed you the technique to select the most economically selectable or feasible option among other alternatives using the present tools method. Today, I am going to show you how to solve a crucial question concerning the method of selecting the best alternative using annual odds method in weather resources. This is the third question. In this question, two alternative plans are considered for a section of an aqueduct. Plan A uses a tunnel and a plan B uses a lined canal and a steel film. Both plans yield the same revenue over the life of the project. Interest rate is 6% per year and the study period is 100 years. Compare the equivalent annual costs of the two plans. Before we start solving this question or problems, I want to express these structures. The first structure is tunnel. Tunnel is an underground passage constructed to divert water from one location to another, often used in irrigation to transport water through hills or mountains. The second one is canal. The canal is a man-made waterway built to convey water for irrigation, drainage, or navigation purpose, typically considered of an open channel. In this case, when you use canal to divert water to common area or an area prepared for crop production. We can categorize the canal into two. The first one is lined canal and a lined canal. In this case, we will see, I'm going to show you canal lining. The method of estimating annual cost for canal lining. Canal lining means the process of covering the bed sides of the canal with impermeable materials such as concrete or cement to prevent water seepage, thereby improving water efficiency. The third one is steel flume. Steel flume is a structure made of steel used to convey water over long distance in a irrigation system, typically elevated above the ground to minimize land usage and facilitate water flow. Now, I'm going to show you step by step on the method of estimate this annual cost for this project. First, we have to calculate capital recovery factors to estimate total annual cost. We can use this formula. Annual cost is equal to annual cost of each project plus present cost of each project into capital recovery factors. We can represent the capital recovery factor as a K, or it is equal to A plus P times K. K is capital recovery factor for these structures. First, we have to calculate capital recovery factors for plan B. Capital recovery factor is estimated like this: I times or interest rate times into 1 plus I the power of n. N is 100 over, in brackets, 1 plus I close bracket the power of n minus 1. Then we have to insert this one in brackets. Okay, this 0 0.06, 0.1, 0.2. So this is capital recovery factor for a canal. Second, on second step, we can calculate capital recovery cost for a canal. This factor, first we have to type equal sign on Excel. Then this capital recovery factor times this one, or first cost of the canal. So this much, or 27,79.8 dollars. Next, we have to take annual operation and maintenance cost for the tunnel. It is 4,000. Is sure? Then, now we can simply calculate total annual cost for the tunnel equal to this value, or capital recovery cost of the tunnel plus annual maintenance and operation cost of the tunnel. It is $31,079.8. Good. Next, we have to calculate total annual cost for a plan B. For the plan B, then capital recovery factor for the canal is calculated by using this formula. Then equal sign I is 0.06 times in brackets 1 plus I close bracket is the power of service life of canal is 100 over in brackets 1 plus I close brackets the power of this one minus 1. We have to insert this one in brackets. T is 0.06. This equal with capital recovery factor of a canal. Then capital recovery cost of a canal is equal to capital recovery factor of a canal times first cost of a canal. Then it is $7,221.3. Then annual maintenance and operation cost of the canal is 10,500. Good. Next, we have to calculate capital recovery factor for canal length. So, in similar way, we can use this procedure, the first and the second procedure to estimate capital recovery factor for a canal length. Then I into 1 plus I to the power of n. Design period of the lining canal is 20 over upper brackets 1 plus I the power of this one, service life of canal length minus 1. Then we have to insert this one in brackets. Right. Then we can calculate capital recovery cost for a canal lining. The equal sign capital recovery factor times first cost of canal lining, it is $50,000. Next, we can calculate capital recovery factor for flow. This one, or interest rate times bracket 1 plus interest rate close bracket the power of service life of the flow 10 over open bracket 1 plus I close bracket the power of 50 minus 1. Now we can calculate or estimate capital recovery cost for a flow. Capital recovery cost is equal to this factor times initial cost of the tunnel. It is $90,000. Finally, we can get total annual cost. Total annual cost is equal to the sum of this one, capital recovery cost for the tunnel, comma, annual maintenance and operation cost of the canal, plus capital recovery cost for canal lining, plus capital recovery cost for a flow. Right? Good. This is much solar. Now we can compare plan A with plan B. Plan B is recommended. Okay? As least cost, as you see, it is $27,790.5. So this best to construct our project. We will start to construct canal with canal lining and a plume to divert water from source to command area or tillage land. This is all about today's lecture. Next, we will see benefit cost ratio, method in water resources,